Here's another radio which I've had for at least a dozen years. That's a Cybernet Beta 2000. Uses Cybernet 135 chassis, which is like a 134 but slimmed down. So we've got a circuit diagram, that's all we have. And these also appear as the Radiomobile 201, the smaller version, the Radiomobile 200, and the Cybernet 1000, just got less knobs. They also appear as the Ford Roadmaster. The small Ford Roadmaster is one of these. The large Ford Roadmaster uses Cybernet 134 chassis, as does the Cybernet Beta 3000 and the Radiomobile 202. So, standard microphone as far as Cybernet goes. Mark has labelled this radio with a red sticker, which could tell us that it does nothing at all. So we'll try and connect it up. Okay, let's see what happens if we try and power it up. It powers up, it's on channel something else. Let's see what happens when we press transmit. I'll switch picture in picture on. There we are. And it does no transmit. So let's see if it's going to do receive. I'll put the frequency counter up. Certainly hisses. 27,79125. And we've got nothing. So it tells me the synthesizer's not running. Switch it to public address. Just watching, that's fine. Back to CB. Oh right, well, seems like we've got a phase lock loop problem on this one. Not had that before, got no experience of that on one of these, and that screwdriver doesn't fit. Of course, it could have been turned into somebody's play toy. Alright, I better plug in the test instruments. Tell you what, we'll use the extension, well, I'll use extension speaker rather than the test instruments in case there's a malfunction, so I don't want to obviously damage the test gear. There is a high-low power switch, it could be faulty. Interesting. It's trying to transmit. And it's transmitting on frequency. So it isn't the phase lock loop. Hang on a minute, what's this great big transistor shoved in there? And this dodgy looking diode? Yeah. Yes, it's transmitting so far. It's drawing 700 milliamps. So why isn't it coming out of the spout, and why have we got no receive? I think what somebody's done there, they've had a malfunction. And instead of trying to find a Far Eastern part, they've put some European device in there. It's a bodge way to do it, but there you go. I don't think that's the red herring. It's that's a previous repair. But if it's drawing 700 milliamps, you'd think it's right up to the output transistor. And then we've got the no receive. I'm trying to see what the output transistor is supposed to be. It's one of the specified ones. To SC1909, is it? It is one in the options list. I'll pause this and have a look. Okay, so we've got transmit and receive now by going through some dry joints, which these don't normally suffer from in the filter area. So, let's see where we are frequency wise. 2779103. We'll pull that up and we can always check it later. And it's that one there. Just like that. I need my clipboard. Right, that's the first thing done. 2779102. Let's see what it's doing on transmit. We'll go to the 3 watt scale and put the main meter up on the inset picture. In 2.5 watts. On channel 40, it's doing 2 watts. On channel 1, it's doing 3 watts. I think that's balanced. Just have to have a look at this circuit. It looks like we're going there and there, but I don't know where we go from there on. Transformer 4, 1, 2, 3, 4. That's it. Two, 3, and 4. That's it. And our current consumption is 877 milliamps. And on low power, the radio is doing 0. Yep. What needed some adjusting. And that was well out. Okay, so we're now at 3 watts. Do we have to mess with that to get the next bit right? Yeah, we do. It's 3.5 at the moment. .6. Channel 1, 3.6. Channel 40, 3.5. and our current consumption is now 1.1. Is low power working yet? Yes, it is. It's doing 160 milliwatts. I'm assuming it is fixed on these. No, it's not. It's 220 milliwatts. I can't read my meter. Deviation. Test it on here first. Wallow. It's reading 2 on here. And like the Cybernet 134, we've got 2 adjustments. One that's be central. Wallow. We'll come back to that with the test set and make sure that that's correct. BCA would have to come up with a technique. What we'd do is look at the Cybernet 134 chassis, look at what you have to do for that, and then transfer it to these component numbers. You can see test point 1 is there. It's resistor 4, the same. It's going to be the same arrangement. Resistor 4. Yeah, well, it'll be fun to find, but it's resistor 4, the same. So it's going to be the capacitor for transmit, and it's going to be the coil there for receive. So you just use what it says in the Rotel 240 manual and transfer it to these components. So definitely resistor 1 there. I can't quite see it. I won't be surprised if that resistor poking up there isn't the one. Anyway, so transmit on the meter. I would suspect the 2 presets down here are meter. So it's not banging across its hello. It responds to audio, does it? How bizarre. I wonder how they do that. Wallow. In which case, it's set right. And when we go to low power, what happens? 1, 2. Oh, that was low. That was high power. And on low power is what we have. Well, I think that's reading too high. So let's see if it's that one. It is. So it's now going to be 1 wallow. How interesting. So our S meter is going to be there. Right, on to receive, and let's look at the detector. Now I have to plug into our test equipment speaker. Now we know the radio isn't going to blow up the test gear. When I saw the red sticker on the back and we got no transmit, no receive, I thought this was going to be right swine, but not so. So at the moment we've got, I'll just put this meter over to SINAD meter so you can see what we're doing. For 12 dB we've got 0.8 for 0.71, and if it will do 20 it's 1.4. Squelch, set that to full. It's coming in at 28 microvolts on full, which is a bit weak. and on threshold, .61. Good. Right, so over to our oscilloscope. We'll put 100 microvolts on the signal generator. And let's go for the detector, which is where? Looks like it's going to be that one. Yep, that was spot on. Now we'll go through the rest of it. Over to SINAD meter. So that, no improvement there. That is a broken core, but it doesn't matter because it's still moving. No improvement now. Let's go for bigger signals. We do the IF. It all looks spot on. I don't think we've got any change. Let's see what happens when we look. So 12 dB. We've got a massive difference. Oh, I didn't see that coming. We've got 0.21. Not 0.2. To 20, 0.5. I didn't feel that was altering much, but obviously it did. Right, let's go for 100 microvolts. And it's going to be the upper adjustment. There we go. That's that. Squelch. Let's put squelch to full. We know it's RV1. There we are, 100 microvolts. Let's go to threshold. Not 0.6 still. That just leaves the deviation to do. I liked these so much at the time that in early 1983 I bought a quantity of these. I was able to sell them to my friends brand new for £55 a piece, which I was really pleased about because I thought they were, you know, as good as it got, which they are. Right. So there's no reason to change what's being done there. Somebody's changed the regulator xenodiode for a heftier one. and they've put a European transistor in instead of a Far Eastern one, which just happens to be bigger but probably dissipates the heat better. So, you know, hey ho, that's how it goes. It's probably supposed to be an oversized TO92 there, and that's a TO5. The point is, the set works, and when I came to this and it was not working, I think, aha, but no, it's just a repair. Not sure why that's on an angle, but I can't see anything leaking out, and I can't see anything humming, so there you go. I could probably change that just for the sake of changing it, but I don't see any need to at this point. I've just touched up one or two bits of soldering around the filtering. And tidied up one or two things which could potentially touch. It's 40 years old. It works. Now then, let's do the deviation. I'll plug it into the test set behind me. See what that says. Alright. We're playing that game, are we? Wallow. Slightly high, how I've got it, it's 2.6. So we'll just drop it down a fraction. Wallow. There we go. I've got the smaller radiomobile on the shelf, and it'd be handy if we did that also this week while I remember what's what on these. I mean, those big radiomobiles were $119.99. Mind you, so was the big Cybernet. And probably the radiomobile. Don't know what the Ford charged. Right, let's put the speaker back. Well, that was nice to do one of our red stickered sets. It's been on the shelf at, I would say since 2014. Unplug that. Unplug that. Finally, the lid is sometimes had a quick spray over, but it looks all right. Pulled out that grandstand Hawk the other day, the remains of. I don't know whether there's any chance of resurrecting that. It'll certainly come in bits. It might be possible to put that together by using a World Sound PT40 like as a case donor. But I don't like chopping up any set that's doesn't need to be chopped up. Right, so we'll plug the aerial in. One and a Roger. Nobody on. You'd think it was as deaf as a post, but we know it isn't. It's about 4:30 in the afternoon. Oh yeah, it's got DX local. It's an RF gain switch. Concentrate the volume and squelch, just to be annoying. Well, there we are, Cybernet Beta 2000, not to be confused with the Kerno Beta 2000. Thanks for watching.